Hello, I'm Tinladimanta. You are watching my video demonstration on loose coupling. So I will explain how to do loose coupling with a simple Java program. Okay, let's assume you have given a set of polygons. So you need to categorize the set of polygons according to their sizes. So let's assume you need to categorize into three categories: large polygons, small polygons, and medium-sized polygons. Okay, and you are given the set of polygons in the form of some parameters. For example, if it is a circle, it can be the radius, and if it is a square, maybe the width and height. And we know calculating the area of a circle is different from calculating the area of a square. And you have no idea in future how far you have to extend your program. It may be for different 100 different types of polygons, maybe 200 different types of polygons. So implementing and maintaining such a program is somewhat difficult. And the most important thing is you have to design your program in an extendable manner. You maybe come up with a solution for 5 different kinds of polygons in your first implementation. So what will happen if you need to extend your program for 20 different kinds of polygons in future? Then you should be able to do it without altering your first implementation. And using the concept of loose coupling is a better way to do it. Okay, let's go to the implementation. So I have implemented the solution for 2 different types of polygons for this example. And I have created a class called class polygon. Inside the class polygon, I have created a method called getType. So in this getType method, it will compare the area of any type of polygon with some numerical values. So according to the numerical values, this method will categorize the polygon into 3 categories. So big polygon, medium polygon, and small polygon. So you can see the implementation. If the area of the particular polygon is greater than or equal to 300, it will categorize as a big polygon, and else if the area of the polygon is greater than or equal to 200, it will categorize as medium polygon, and else it will categorize as a small polygon. So this is the getType method of my polygon class. And as I told you before, you have no idea up to how many number of polygons you will have to extend your program. And without knowing what are the types of polygons actually, how it is feasible to calculate the area of the polygons. To overcome that problem, I have created an interface called iPolygon. Inside the iPolygon interface, I have created a method called getArea. Okay, and in my polygon class, I have created an iPolygon reference. So iPolygon. Using this iPolygon reference, we can access the getArea method of the iPolygon interface. Okay, you can see inside of the calArea method, we are accessing the getArea method of the iPolygon interface, and we are calling getArea method inside our calArea method. And you can see the calArea method returns the actual value of the getArea method, and inside our getType method, we are calling the calArea method. So that means the double area will store the value returns by the getArea method. Okay, and I have created a parameterized constructor for the polygon class. So we are passing a iPolygon type reference as the parameter to the constructor. So we are assigning the passing value for our iPolygon reference. Then our iPolygon reference will store the passing value of the constructor. So in here, what I am trying to do is, each and every time an object of polygon class is created, we are passing an actual polygon type as a reference. So we are actually calling the getArea method of the particular polygon type. Okay, let's look at the actual implementation of the different polygon types. So I have created a class called class circle. The class circle implements the interface iPolygon, which means the getArea method of the iPolygon interface is implementing inside the circle class. Inside the circle class there is a variable called radius. So the getArea method of the circle is returning the calculated value of the particular circle, and also there is a parameterized constructor for the class circle. Each and every time the object of a class circle is created, we are passing a radius value. So this radius value will pass to the our radius value, and the area of the particular circle will returns from the getArea method. And this is my triangle class. Triangle class is also implementing the iPolygon interface, which means the getArea of the interface should implement inside my triangle class. And there are two variables, base and height, and there is a parameterized constructor for my triangle class, and I am passing the base and height values as parameters, and you can see the base and height values are assigning for these two variables. Using these two variables, the getArea method is calculating the area of a particular triangle, so and it returns the calculated value. Okay, and this is the implementation of my triangle class. And if you can remember, I am passing an iPolygon variable for my polygon class constructor, which means I am actually going to pass either a circle object or either a triangle object for my polygon class constructor, because both the circle class and the triangle class are implementing the iPolygon interface, which means these two classes are the type of iPolygon. Okay, though I am actually passing either a circle object or a triangle object into my polygon class constructor, the polygon class doesn't know anything about either circle class or triangle class, which means inside my polygon class there are no reference of triangle class or circle class. So only there is a reference of iPolygon interface, which means here we are loosely coupling my polygon class and each and every particular type of polygon classes. Okay, and here is my main class. In my main class I am creating a circle with radius of 14, and I am creating a new polygon object. To the polygon constructor I am passing the newly created circle. Okay, if you can remember, the constructor of polygon class accepts the type of iPolygon variable. So the circle method is implementing the iPolygon interface, which means the circle is a type of iPolygon interface, which means we can pass the circle object into the newly created polygon object. So I am going to print the category of this P1 object, P1 polygon. So the category of any polygon is given by the getType method of the polygon class. Okay, you can see the getType method returns the category of the polygon. So in here I am going to print the category of the newly created polygon, which means this circle. Okay, and I create another polygon P2. I am passing a new triangle into this polygon object. So as you can remember, this is my triangle constructor. It accepts base and height. So I am creating 20 and 11 triangle and pass the triangle object into P2 polygon, and I am going to print out the P2 polygons category. Okay, and let's run and see. And here are the results. Type of polygon 1 big polygon, type of polygon 2 small polygon. Okay, and what we have done here is loosely couple the polygon class with this circle class and the triangle class. So we are passing these objects into the polygon class, but polygon class doesn't know anything about circle class or the triangle class, which means inside the polygon class there are no reference of those two classes. Okay, let's assume you are going to extend this solution for another square polygon type. Okay, when you extend in this solution into another square polygon type, all you have to do is create a separate square class and implement the square class with the iPolygon interface, and implement the getArea method and write the equation for calculating the area of a polygon. Okay, so you don't have to alter your first solution, these classes you don't have to alter these classes in order to extend your program. Okay, that is the advantage of the loose coupling.